Alright, for number 68 we are simply multiplying these two terms times these two terms, which means each term here has to hit each term here. Don't be intimidated by the fractions, you just got to deal with them. So this x has to multiply that x. That'll give us x squared. This x has to multiply a positive 1/5, so that's plus 1/5 x. This x could sit up top, but I prefer it on the side. So that takes care of the x hitting each term. And now you need this negative 2/5 to come in and hit each term. So negative 2/5 times x is negative 2/5 x. Okay? And then negative 2/5 times 1/5. You can probably do it in your head, but it might get confusing. Just be careful with your fractions. 2/5 times 1/5 is equal to 2 times 1 is 2. 5 times 5 is 25. Okay? And negative times positive will be a negative. So this is negative 2 25ths. And you can combine your two middle terms here. So you have this positive 1/5 x, negative 2/5 x. Alright, negative 2/5 is larger, pretty easy to tell by the numerator. So it's going to be, it's just hard to show it, but you just know 1/5 minus 2/5 is a negative 1/5. I guess technically I would show it like this. If I had 2/5 and I was going to subtract 1/5, the result would be negative 1/5. Alright, so that's what we get from combining these two. Negative 1/5. X just comes along for the ride, and you bring down your other two terms. So this x squared and negative 2 25ths, and we just multiplied this. And you might notice, you know, maybe in the past you're a little bit intimidated by fractions, but it really wasn't much work here. You were multiplying and then combining like terms, and you obviously had common denominators. You want to start noticing the patterns that show up. It's going to save you a lot of headache in the long run if you can start noticing these patterns. But again, the fractions didn't end up causing much trouble here. Okay, 68. We're also going to do 73. So let's take a look at 73 here. Sorry for all shuffling around. 73. Ready to go. Something interesting about this one is, notice how, maybe I'll zoom in a tiny bit. Okay, notice on 73 here, you have 7p the same, and you have a 3. The only difference is this one's positive, this one's negative. You want to start noticing that, because there's a pattern that's important to observe. All right, but we'll start out just the same way we always do. 7p times 7p, that gives us 49p squared. Okay, and then this times negative 3 is negative 21p. All right, and then we take care of sending in this positive 3 to each term, so that'll be plus 21p, and then positive 3 times negative 3 is negative 9, and you're going to combine your two like terms. Notice these like terms end up sitting in the middle, and remember, both of these binomials were the same except for the sign. Okay, and what happens is you end up with a 21p, a 21p. One of them's negative, one of them's positive. When you combine them, you get 0. So in effect, they cancel each other out. I'm not even going to write the 0. I just bring down 49p squared and this negative 9. Okay, I didn't have to write plus 0, and that was the result of them. You're going to want to notice this pattern because you're going to have to start realizing that this is a difference of perfect squares, and you're going to have to know how to go in the other direction. For Unit 2, we go from here to here. When we get to Unit 3, you're going to have to go from here back up to here. Okay, so you're going to have to start picking up on these patterns. So that was 73. Let's take a look. 75, another fraction showing up. But hopefully you're getting more comfortable with these. And again, notice you have everything here is the same except for those signs. So I want you to start anticipating your middle term is going to disappear. And the shortcut would be I can just square the first term, square the last term, and I know it's going to be a difference because negative times positive is negative. But I'll go down the longer road to start here. Okay, so 3/8y times 3/8y. Remember, 3/8 times 3/8 is going to be 9/64. Okay, we basically just squared this thing. So that gives us 9/64 y squared. Then 3/8 y times a 9, and maybe I'll write that way over here. 3/8 times 9, I wish that was a fraction, so I'll write it as 9/1. And what do I get? 27/8. Okay, and it's positive. Don't forget your y. So we've got plus, as crazy as it is, just 27/8 y. Okay, then you deal with sending your negative 9 to each term. So negative 9 times 3/8 y. Well, if 9 times 3/8 gave me that, negative 9 times 3/8 is just going to give me the negative version of that. Okay, so that's minus 27/8 y. And then finally, negative 9 times positive 9 is negative 81. And again, your middle two terms, and you want to start reading it. Everything's the same except for the signs. These middle two terms are going to cancel each other out. Positive 27/8 y, negative 27/8 y. So that becomes 0. I don't even need to write it. Okay, so I'm left with 9/64. And I'm running out of room. Better zoom out a little. That should help. 9/64 y squared, and a negative 81, or 9/64 y squared minus 81. You can say it either way. And when you get to Unit 3, you're going to want to start realizing it's a difference because of that sign. 81 is a perfect square. 9 times 9 is 81. And 9/64 is a perfect square. The square root of 9/64 is 3/8. Okay, the square root of y squared is y. Okay, but for Unit 2, all you have to do is get from here to here. All right. Let's see, 75. We're going to tackle a couple more. Notice when we get down to 76 here, it's no longer multiplication. And maybe I'll try zooming in a little. There we go. This indicates division. You have your fraction bar, or your division bar, whatever you want to refer to it as. Each term here has to get divided by a 7. So excuse me, don't just try to say, oh, 7 goes into 7 once and 7 goes into 42. It doesn't apply to just that term. This division bar says that this 7 applies to each term. So The safest way to proceed is you write 14x squared over 7. This minus sign, I'm just going to keep it right up there. 42x over a 7. All right, and this minus sign, I'm just going to keep it up there, or negative. The words are interchangeable. 28 over 7. Okay, and you've seen this before. I'm going to clean this up, but just to digress for a second, if you had 3x over 5 plus, let's say, we'll just say 2/5, okay? If you had this, you would be able to add, in a sense, you would just get, this is kind of not where I want it, you would get 3x plus 2 all over a 5, okay? So when you see this, you have to realize it can be written that way. And let's get back to the problem at hand here. We can clean each of these up. So I'll use this. 7 goes into 7 once, 7 goes into 14 twice. So here we're left with 2x squared. 7 goes into 7 once, 7 goes into 42 6 times. So we're left with negative 6x. And 7 goes into 7 once, goes into 28 4 times. So we're left with negative 4. Okay, so we simplified our first one. And let's see, number 78 we'll grab from over here. We just got 2 more to take care of here, folks. Number 78. And again, my suggestion is rewrite this expression with a negative 3x to the 5th under each term. Okay? And let's see what I've got here. These signs I'm going to keep up in the numerators. This sign I'm going to keep in the denominators. All right, so I guess I'll start out. We have our negative 9x to the 6th over negative 3x to the 5th. All right. Then we have a negative 15x to the 5th over negative 3x to the 5th. And basically, with these signs here, it's still saying we're going to add or subtract. I didn't put a dot. I don't have parentheses. So I'm preserving the addition and subtraction that's supposed to happen between these terms. Okay? But I'm just showing it with negative 3x to the 5th underneath each one. So this is negative 15x to the 4th over negative 3x to the 5th. Okay? And again, you're not being told to multiply, so by default this is going to be addition or subtraction. Sorry, my 5s are getting a little weak here. Alright, now let's clean these things up. Negative divided by a negative is going to be a positive. 3 goes into 3 once, 3 goes into 9 3 times. You have x to the 5th, x to the 6th. All 5 of them are gone. Subtract 5 from 6, you're left with a 1. So all of this turns into a positive 3x. Alright? And this whole thing is gone. Now we'll turn our attention to this one. Negative divided by a negative is a positive. So this thing is going to be positive. 3 goes into 3 once, goes into 15 5 times. X to the 5th goes into x to the 5th once. So those become 1s. 5 times 1 is 1. So all of this, whoops, forgot my 5. 5 times 1 is 1. 5 times 1 is 5. Let's try that. Oh, that looks much better. Okay, and then over here, there were no x's left. X to the 5th goes into x to the 5th one time. Negative divided by a negative is going to be a positive. And 3 goes into 3 once, goes into 15 5 times. X to the 4th, all 4 of these disappear, and you subtract 4 from 5 and you're left with 1. I mean disappear. They divide and cancel with 5 x's in the denominator. So however you think of it, but basically I cross that out, subtract 4 from 5, and I'm left with a 1. So I have a 5 up here in my numerator, and I just have an x in the denominator. And some people might have a little trouble reading these signs, okay? Maybe I should have crossed them out when I used them, because you might have been thinking here, oh, isn't that a -5 or something? No, I used up these signs, okay? Back here I said negative divided by a negative is positive, so those signs are gone, okay? I used them up. Here I said negative divided by a negative is a positive, so I used them, okay? They're gone. And again here, negative divided by a negative is positive, so they're all gone. And this is our answer. And obviously that leading plus is not necessary. And we're going to do one more, number 80. Alrighty. Again, I suggest rewriting with this 3xy underneath each term because it applies to each term. So we have 3x to the 3rd y to the 3rd over 3xy, then plus 6xy over 3xy, then minus x squared y squared over 3xy. Okay, and then we'll cancel common factors. So 3 goes into 3 once, 3 goes into 3 once. I'm going to lose 1x down here, so I subtract 1 from 3. I got 2. Lose that y, subtract 1 from 3. I got 2. So this term all cleaned up to be x squared times y squared. All right, that's our first term. This next term is going to be positive. 3 goes into 3 once, 3 goes into 6 twice, and xy goes into xy 1 time, so that's 2 times 1, or simply 2. All right. And then this is negative divided by a positive, that's going to be negative. And let's do these individually. This x cancels, so you subtract 1 from 2, you're left with 1. This y cancels, subtract 1 from 2, you're left with 1. And so there is a 1 sitting up top. Actually there's a x to the 1st and y to the 1st up top. And you have a 3 in your denominator. So that would just be written x, y over 3. Slide this up a little. And that takes care of number 80.